What if I told you one of the biggest problems facing AI in 2026 isn't smarter models, better data, or even more semiconductor chips? It's actually heat. AI data centers are becoming incredibly powerful, but that also means they're becoming incredibly hot. And as chips get faster and more compact, cooling them is becoming one of the biggest limits in computing. We have reached the point where performance is no longer limited by intelligence, but by temperature. And the surprising material that might help solve the problem is diamond. Not jewelry diamonds, but synthetic lab grown diamonds. When we think about cooling data centers, we usually imagine giant fans, cold rooms, or liquid cooling pipes. But the real problem starts much deeper. The heat is created inside the chip, right where billions of tiny transistors are switching on and off constantly. Traditional cooling methods mostly cool from the outside, but the hottest spots are buried inside the device. So it's kind of like trying to cool a fire inside a wall by turning on the air conditioner. It helps, but it doesn't directly reach the source and tackle the issue. Modern AI chips are incredibly dense. We are packing more and more transistors into smaller spaces. And in some advanced chips, that number reaches into the hundreds of billions. Every time electricity moves through these tiny circuits, some energy gets converted into heat. And when isn't enough space for that heat to escape, the chip starts to slow down itself to survive. That's called throttling. So, the issue isn't just the chips getting warm. The issue is heat can directly limit how much AI compute we can actually use. This is where diamond becomes really interesting, because it is one of the best materials on Earth at regulating heat. Its thermal conductivity is at about 2.2 to 2.4 kilowatts, which is several times higher than copper. A simple way to think about it is this. In silicon, the heat moves like a ball bouncing around a pinball machine, whereas in diamond, it moves like traffic on an open highway. And the best part is that diamond can move heat extremely well while still acting as an electrical insulator, which means it can sit very close to sensitive electronics without short-circuiting them. That combination is what makes it so valuable. Now, this doesn't mean companies are taking engagement rings and putting them inside AI servers. These are synthetic diamonds grown in labs. One method uses extreme pressure and heat, kind of like mimicking conditions deep inside the earth. Another method, called CVD, uses gases such as methane and hydrogen to build diamond layer by layer. And the synthetic diamond is already common in the industry. The US Geological Survey says that about 99% of the US industrial diamond consumption is synthetic because its quality can be controlled and customized. So the key idea is this: we're not just finding diamonds anymore, we're engineering them. Other materials like silicon, silicon carbide, and gallium nitride are already important in electronics. But diamond has a rare mix of properties. It moves heat extremely well, blocks electricity, handles high voltages, and can survive harsh environments better than many traditional materials. That's why researchers are looking at diamond in two ways. First, as a cooling layer for existing chips, and second, as a possible semiconductor material for future chips during manufacturing. The first path is the most practical for AI data centers. Instead of replacing today's chips, diamond can be added as a thin cooling layer, almost like a heat-spreading blanket. The challenge was that growing diamond directly into the chips used to require extremely high temperatures, which could damage the electronics. But Stanford researchers developed a lower temperature method, below 400 degrees Celsius, that allows thin diamond layers to be integrated much closer to active devices. This can lead to a temperature drop of up to 70 degrees Celsius, which is massive in terms of chip cooling. This becomes even more important for future 3D chips, where layers are stacked like floors in a skyscraper. The middle layers can trap heat, so diamond heat spreaders and tiny vertical pathways can act like emergency exits for the heat. The second path is even more futuristic, making the chip itself out of diamond. This matter in extreme environments like nuclear reactors, satellites, space expeditions, and defense systems. Diamond based semiconductors could operate at much higher temperatures, handle high voltages, and resist radiation far better than ordinary silicon. Well, that doesn't mean your next laptop will have a diamond processor in it. But it does mean that diamond could become critical for places where normal electronics simply can't survive. There's also a bigger strategic angle to this. Many advanced chips depend on specialized materials and complex global supply chains. Synthetic diamond, in theory, can be made from gases like methane and hydrogen, plus electricity. That could make future hardware supply chains more secure, more local, and less dependent on rare or restricted materials. So the big picture is AI is running into a heat wall. Fans, liquid cooling, and better data center design will still matter, but they may not be enough on their own. And maybe, just maybe, the next generation of AI won't be cooled by bigger fans, it will be cooled by diamond.